This video uses vector methods to prove that the angle inscribed in a semicircle is a right angle. So looking at the diagram that we have there, we are going to consider triangle ABC. And you can see that we have defined some vectors. So let vector OA equal A, vector OB equal B, and vector OC equals C. And they are on our diagram. Now, angle BAC is the one that we want to show as a right angle. Now, it's only going to be a right angle if vector BA is perpendicular to vector CA. Now, whenever we see, when we're doing with vectors, we see perpendicular, we're going to be thinking of dot product. So we need to show the dot product between BA and CA equals 0. And that's because cos of 90 equals 0. Now with that diagram, we can see that the magnitude of vector A, vector B, and vector C have to be the same because they're radii. So let's start by looking at BA, which is this vector here. BA is going to be BO plus OA. So BA, vector BA equals BO plus OA. So that's minus B plus A, or A minus B. Then looking at vector AC, and that's going to be CO plus OA. So vector CA is going to be equal to CO plus OA, which is minus C plus A, which is A minus C. So looking at the dot product between those two vectors, it's going to be vector A minus B dot product vector A minus C. Expand that out. Now when you look at that, this vector C is going to be the same as minus B because they're radii of the circle. But they're in opposite directions. Also recall that vector A dot vector A is the magnitude of A all squared. So let's go and replace the magnitude of A all squared. So we're replacing C with negative B. So this is going to become plus dot product of A and B minus A dot B. Replacing C with negative B. So this is going to be minus the magnitude of B all squared. Middle terms cancel. So we're left with the magnitude of A all squared minus the magnitude of B all squared. And that has to equal 0 because the magnitude of A is equal to the magnitude of B because they are radii. So since since the dot product between vector BA and CA is equal to 0, vector BA and CA must be perpendicular, which shows that the angle in the semicircle is 90 degrees, and our proof is done. So now we've proven that the angle in a semicircle is right angle through geometric methods and also through vector methods.